The sun is our local star, and it's really, really big. In fact, 1 million Earths could fit inside the sun. The sun is so big that it is 99.86 of all the mass in our solar system. That means the 8 planets, the several hundred moons, the 5 dwarf planets, the tens of thousands of asteroids, and the several trillion comets. Our solar system is very big and very busy. The sun makes life on Earth possible, and we know that the Earth, and probably the sun, is around 4.5 billion years old. It's an amazing star, our sun, but in the universe it's rather ordinary. It's medium-sized and middle-aged, a type called a yellow dwarf. The sun's about halfway through its life of 10 billion years, and in another 5 billion years the sun will change from being a yellow dwarf to a red giant, when it will expand and engulf the planets Mercury, Venus, and Earth. After the sun becomes a red giant, it will then collapse to a white dwarf about the same size as Earth. But don't worry, that's 5 billion years away. The temperature in the sun's core is around 15 million degrees Celsius. The massive nuclear furnace generates energy in the core and creates gamma radiation, which takes a very long time to travel to the surface, about 170,000 years. When the gamma radiation reaches the surface, the temperature is only 5,500 degrees Celsius. And the black areas we call sunspots can be as cool as 4,000 degrees Celsius. On the surface of the sun, the radiation becomes what we see as sunlight. The sun is a very long way away, nearly 93 million miles, or 150 million kilometers. The Earth revolves around the sun in an elliptical or oval shape, and at different times of the year, the Earth is closer or further away from the sun. Sunshine, the light from the sun, takes 8 minutes to reach the Earth. Of course, it travels at the speed of light, which is 300,000 kilometers a second. But light from the moon only takes 1.3 seconds to reach us, because the moon is a lot closer. The Apollo spacecraft took 3 days to fly to the moon, but would take 156 days to reach the sun. But spacecraft can't fly too close to the sun, or they would burn up. Energy released by the sun during magnetic storms causes solar flares. We see these as sunspots. The sun generates solar wind, which is a stream of plasma particles. When this solar wind hits Earth's atmosphere, it causes a beautiful aurora, which we know as the Northern Lights and the Southern Lights. Coronal mass ejections, or CMEs, are the most massive eruptions of solar magnetized plasma. A huge CME can damage our satellite communications, cause power blackouts, and disable GPS signals used for navigation. The biggest recorded geomagnetic storm was the Carrington event in 1859, when the northern lights were seen as far south as the tropics and telegraph lines melted. The effects of a powerful CME on Earth would be dramatic, which is why we monitor the sun's violent eruptions and explosions with a fleet of satellites.